You certainly can ask questions. Just because I'm recording doesn't mean you can't answer questions or ask questions. All right. Today we're going to talk about rational functions and their graphs. The simple rational function that is in this format, that was a transformation of the parent graph. Remember what the parent was? Y equals 1 over x, okay? And some reason I can't see my cursor at all. Let's see if I can get it to look like something would be nice so I can find where I'm at. Anyway, I'm going to get rid of that because I put it too far over because I couldn't see where I was. Anyway, all right, so that graph was, oh, I did it again. Something like this. Well, it is this. It ran along, it had asymptotes of the x and the y axis, and it was in first and third quadrants. Okay, so for whatever reason, my smart notebook is acting very strangely and not giving me anything for, like usually it shows a pencil or at least an eraser. Oh well, I'll try. Okay, so a simple rational function, what's happened, what does A do? All right, stretches which way? Okay, vertically, and then K shifts it, oopsie. It's a vertical shift, K units. And then H was a horizontal shift. Okay, so I just talked about it real basically there. Now we'll get a little more specific as to what's going on with these graphs. If I can find my cursor again. Alrighty, what's going on here? That would be a stretch by 3 times. You know what I'm talking about? That A value, okay? And then it would be a vertical shift down 1 and a horizontal shift. What's it going to be, right or left? Okay, right 4. All right, I just thought we might be for good practice to describe those. Hopefully I can see my pen. Now, what we found out was the horizontal asymptote. That was determined by the K value. All right, so the horizontal asymptote was Y equals K for this case, and the vertical asymptote was X equals H. So for this one, the Y is -1. That's for the K is -1. So Y equals -1 is our horizontal asymptote, just looking at that equation. You will need to know this for your quiz that will have no graphing calculators. The vertical asymptote is X equals 4. The domain would be all reals, and I was telling you how we could use that big R for the real numbers, except X can't equal 4, and for the range, all reals except Y can't equal -1. All right, this one would be reflected over, I wrote that wrong, I guess I can't see my dang pen, reflected over the x-axis. Okay, and then vertical up 2, horizontal left 3. So the horizontal asymptote would be Y equals 2, the vertical asymptote X equals -3. Okay, the domain, all reals, except X can't equal -3, and the range, all reals, except Y can't equal 2. I'm going to pause for a minute here and see if I can. All right, so I got it. Yes. Horizontal lines are Y equals lines. Horizontal lines are Y value lines. Vertical lines are straight up and down. They're X equals. You have to hit the X axis. If it was Y equals, it would never hit the X axis. Is that what you're talking about? Are you okay? Are you talking about why the equation is y equals -1 and x equals 4? Are you talking about why? Is that what you mean? Right. Oh, right here. Okay. If you're moving horizontally left 3, that means that you're shifting a vertical line to the left. Because the asymptote, the vertical asymptote is x equals 0 for the original parent graph. If you shift left 3, you just shifted a vertical line left 3. Does that help a little bit? I get you. I see what you're saying about why that would be a little confusing. Okay, so a horizontal shift of a vertical line is what's happened. Then maybe that helps, I hope. So try not to associate the shift of a graph with the asymptote. Does that help? Maybe, I hope, I don't know. All right, so this, I get your point. I'm not going to write these down anymore. What's the transformations? Let's just mention it. This would be stretch vertically twice as fast. And then this would be a horizontal asymptote would be y equals 4. Okay, the vertical asymptote would be x equals 3. Oh, darn it, I lost my cursor again. Oh, well. Domain is all reals except x can't equal, and I know I'm repeating, but I want to make sure you know x can't equal 3. Maybe it'd be nice if the domain and the range were flopped here, but the range, all reals except y cannot equal 4. All right, and this one would be reflected over the x-axis, and you have no idea how frustrating this is, that this is not working properly. But this graph would not be in like 1 and 3. It would be flopped, sort of shifted around that way. And then it would be shifted to the left 5, so left 6. So the horizontal asymptote is, okay, y equals -5, and the vertical asymptote, x equals -6. Thank you. All reals except x can't equal -6, and this would be all reals except y can't equal 5, -5. If I can find where to write the negative sign. All right. Rational functions in the form. This is new. Okay, so we already had studied those other graphs last time. Now we have p of x over q of x where you can't see the shifts. All right, there aren't any, you don't see an h, you don't see a k. You have to figure them out. Okay, so the way that you're going to look at them is x-intercepts are the real zeros of p of x, the numerator. So what would you do? You would factor the numerator and find zeros. Okay, if you find the zeros, and I think I just spelled that wrong, it's Z-E-R-O-E-S. No, that is O-S. Factor to find, and then find the numerator of the numerator. Just make sure you can read that. Factor numerator, find the zeros. Those are going to be your x-intercepts. Okay. To find the vertical asymptotes, that's when you're going to look at the denominator. Okay. So you will factor the denominator. Okay, and then set to 0 to find your zeros. Okay. Those will be your vertical asymptotes. They will not be x-intercepts or y-intercepts. They will be your vertical asymptotes, VAs. And then you're going to have a hole in your graph, which is called a point discontinuity. Yes? Here? Denominator, sorry. Denom. I abbreviated. Maybe I shouldn't have. I just underlined denominator. Factor the denominator and set to 0. Oh, I can't find my cursor. All right, so you're solving for the denominator's zeros, and that will give you your vertical asymptotes. Now, You have a hole in the graph if there is a common factor in the numerator and denominator. Okay, so an example, if you had x minus 1, x plus 2 on top, and then on the bottom you had x minus 1, you would have a hole, okay, at x equals 1, and then you would find the point, 1 something. Okay. Horizontal asymptotes are found by comparing the degree of the numerator and the denominator. So I'm going to give you some rules for that. You're going to compare numerator to denominator. Make sure you know where those are. All right, so let's try some graphing. I think that's what, oh no, it's talking some more. So bottom heavy. Bottom heavy means the degree of the denominator is bigger than the degree than the numerator. If that's the case, then you have a horizontal asymptote at y equals 0. Example of bottom heavy, x over, say, x squared minus 4. I just made something up. Okay, that's just an example. Then you would have y equals 0 would be your horizontal asymptote. If it's top heavy means the degree of the numerator is larger than the degree of the denominator, then there is no horizontal asymptote. So example, if you had x to the third over x squared minus 4, I'm just made up something different, that would be top heavy. So it would be no H horizontal asymptote. It would actually have one that's called an oblique asymptote, and that's you're gonna do in pre-calc. I could show you maybe something what that means. Say it's a line that would oblique. Remember, oblique lines are just slanted; they're not vertical or horizontal. Remember back in possibly, well, in your geometry class, you had oblique prisms or cylinders, and you could still find the volume of them, etc. All right, that's oblique. And equal weight. If your numerator and denominator have the same power, top and bottom, so x squared over x squared plus 1, example, then you would have a leading coefficient over leading coefficient. So for this case, y equals, your horizontal asymptote would be y equals 1, because that's leading coefficient over leading coefficient. All right, let's try some. So first you want to determine, you guys got to flip your page. I'm going to note, since we just visited top heavy, bottom heavy, equal weight, this one is same power, top and bottom, so this one is equal weight. So that would be the thing we just discussed. So let's talk about the horizontal asymptote. The horizontal asymptote is going to be lead coefficient over lead coefficient. I guess I'll use an F so you know what I'm talking about there. What's the leading coefficient of the top? 1, and the lead coefficient of the bottom is a 2. So the horizontal asymptote will be y equals 1/2. All right, let's go ahead and put that on our graph. All right, the x-intercepts, those are found, they are the zeros of what? Now, this is the stuff you've got to remember. Zeros of the numerator, okay? What would make that numerator 0? Yeah, if you said x plus 1 equal to 0, you would get -1 if you solve that. So that would be -1, 0. It's an x-intercept. We need to write it as a point. Y-intercept. Now think about it. You've done y-intercepts for a long time in your math careers. What do you do when you want to find a y-intercept given an equation? Yes, put in 0 for x. So I need you to write the point 0 something. So we're going to substitute 0 in for x in the equation. And that would leave us with 1 on the numerator, -4 on the bottom. So that's -1/4. Okay. All right, I'm going to plot all this in a minute. The vertical asymptotes are found by finding the zeros of the denominator. So what would make that denominator 0? It would be a 2. So that would be x equals 2. Now I could factor that denominator, right? But all it would be to take factor out a 2. All right, so I got a vertical asymptote at x equals 2. All right, now, how did I find that? Maybe we need to write that down. If you'd like to write down that we did 2x minus 4 equals 0, 2x equals 4, so x was 2. That's how I got it. All right, now, the domain, all reals except x can't equal 2. And the range, all reals except y can't equal 1/2. Y can't equal 1/2. You could write that in interval notation. It would look like this for a domain, negative infinity to 2, union 2 to infinity. And if you were to do the range in interval notation, negative infinity to 1/2, non-including, and from 1/2 to infinity. Okay, that's probably the last time I'll even write that in that form. Didn't want you to forget about your interval notation, though. Okay, let's start plotting some stuff. We've got x equals 2 as a vertical asymptote, so I'll go ahead and dash in a vertical line. Okay, we've got a y-intercept of 0, negative 1/4. Right around there. I've got an x-intercept at negative 1, 0. So now I can tell what's going on with this graph. The shape is still the same as the ones that we graphed the other day. You need to run along your asymptote. You cross at negative 1, cross at your y-intercept, and then run down the other asymptote. If you wish, wanted to, plug in a couple more numbers. The ones I suggested to you would be left of your vertical asymptote. So I would have put in a 1. If I put 1 in here, I'd have 2 on top, and on the bottom I'd have 2 minus 4, which would be negative 2. 2 divided by negative 2 is negative 1. So I've got 1, negative 1 as another point. The other point I would plug in would be 3, because it's to the right of the vertical asymptote. If I substituted in 3 in there, I would have 3 plus 1, which is 4 on top. I'd have 2 times 3, which is 6. 6 minus 4 is 2, and 4 divided by 2 is 2. So 3, 2 is a point on the graph. If you'd like to put in some more, you could, but I'm thinking let's just sketch. And run along your asymptotes. Make sure you put arrows on your end behavior. Hey, any questions, or anybody still need this? All right, let's try another. Number 6 is that look at the weight, look at the degree of the numerator versus degree of the denominator. You only care about the highest power. The highest power of the numerator is x squared. The highest power is in the denominator is also squared. So these have equal weight. Again, which means we're going to do lead coefficient over lead coefficient. Okay, what's the leading coefficient on these? They're both 1. Yep. So our horizontal asymptote is y equals 1. Okay, x-intercepts. Let's go ahead and factor that numerator. It would factor to x minus 3 times x plus 1. Denominator factors to x minus 2 times x plus 2. And again, order of those doesn't matter. There's no common factors to the top and the bottom. So I now look at my numerator for my x-intercepts. What are the zeros of the numerator? 3 and negative 1. Okay, so 3, 0 is one x-intercept, and negative 1, 0 is the other. I'm going to plot them right now. 3, 0 and negative 1, 0. I have a horizontal asymptote at 1. Might as well sketch that in. Don't want to forget any of the things we're writing down. Y-intercept is always found by substituting 0 in for x. If you did that, you'd have -3 on the top. And on the bottom, you'd have, -3 over -4, which will be +3/4. 0 3/4. Oh, that's still underneath there, isn't it? I did that right? Yeah, 3/4 is less than 1, so it's going to be under here. Wow, I've got 2 vertical, wait, those are x-intercepts. What's going on in this thing? Well, maybe you're wondering the same thing because you see all this stuff starting to, how's this graph going to go? Well, we need to get these in. Our vertical asymptotes are x equals 2 and x equals -2. We've got 2 of them. Now, if you have a graphing calculator, this is probably the time when you'd want to go look at it, but I'm not going to yet. I'm going to wait. Okay, our domain is all reals except x can't equal 2 or -2. All right, so what would I do maybe? Let's say you wanted to make a t-chart. Hello, do you have a password? Oh. Are you coming from another class? Okay, I hope you're okay. Did you get your you have the packet and stuff, right? Did you guys pick up the homework request? All right, we decided to plug in something to the left of our leftmost asymptote, which would be -3. And that'll kind of give us a clue to what section of the graph we're in. Now, these graphs do some strange stuff when they've got 2 vertical asymptotes. There's either going to be a chunk in the here, and here, and then a twist or something in there, or maybe a hump in there, or it's going to be something here and here, or it might even be up there and up there. So we're going to find out. If you substitute -3 in, that would be 9 plus 6, 15 minus 3, 12. I'm just doing it in my head here. 12 over, and then on the bottom I'd have 9 minus 4 would be 5, 12/5. And that is 2.4. -3, 2.4. So I just found out that this is going to be the chunk in here. Oops, I actually hit the way too far edge and it was turned black. Okay, so that's what's going to happen in that section. And I did that, I figured that out just by getting that 1 point. Now I already know something that's going on in here, because I've got an x-intercept and I have a y-intercept. Remember how we plotted those already? They're already things on the graph. So let's plug in something that we haven't that's in this section, which would be 1. So if I plug in 1, I'm going to have 1 minus 2, -1 minus 3, that'd be -4. On the bottom, I'd have 1 minus 4 would be -3. So that's +4/3. You're not knowing what I'm doing? You just have a funny face on. So. Okay, so I'm just checking with you. All right, so all I did was substitute in 1, and I did some just plugging in my head. All right, we're okay that we got +4/3. So that means we're above here. 4/3 is more than 1. So that means this thing did a twist in here. Because it's got to run along that asymptote. Okay. Now, what's going on over here? Can't we already tell? We already have an x-intercept in that section. So that means it's running along this asymptote till it hits there, and then it runs along the other one. Okay, so that is a way to get a graph without having a graphing calculator. It is doable. Want to verify. Let's go to y equals, clear, at least let you see it. Now, when you type these rational expressions in here, you've got to put parentheses in the numerators and denominators. I absolutely forgotten what this equation was to begin with, but it was x squared minus 2x minus 3. I'm trying to look it up here. X squared minus 2x minus 3. Close the parentheses, then hit divide. Parenthesis, x squared minus 4. But don't forget, there will be a quiz where you have graphs you have to do without the aid of the calculator. Plus, this calculator, this one shows this one pretty well. But what will it not show you very clearly? Yeah, those asymptotes. And you've got to have them on your grapher. You know, how can you guess for me what that horizontal is? You can make a guess, but if it was a fraction, you're not gonna probably get it right. And the other thing is, you can't see it if it's a fraction in your table either. Which ones can you see in your table? Because you already know what they are. Right here, see? Error. That's your vertical asymptote. At -2 and +2. You find an intercept right there. You can find some things in here if they're nice points. But if they're fractions, they're not going to show up in your table. Okay? All right, let's try another. So let's see. We've got an x to the first on the top and an x to the what on the bottom? If you multiply, so this one is bottom heavy. Go back and look at the rule for bottom heavy. Bottom heavy is going to give you a horizontal asymptote of y equals 0. Okay, where is that? HA, y equals 0. The denominator is already factored, so I've got my vertical asymptotes at 1 and -4. Zeros are found by, okay, I don't know why these are all out of order, but the domain will be all reals except 1, x can't equal 1, or -4. I'll check out the range in a minute. The zeros are what makes the numerator 0, so that's what that means. That's actually an x-intercept. Let me maybe preface that. That would be the point -5, 0. Okay. All right, let's start putting some stuff on our graph. -5, 0, x-intercept. Y equals 0, horizontal asymptote. So I got to dash my, uh-oh, did I do something wrong? I sure did. Look at that. How did I put that in the wrong place? That was silly. Thank you for stopping me immediately there, Addison. Okay, I got my horizontal asymptote. Of course, this, oh, wait a minute. Timer, you just said that the horizontal asymptote's y equals 0, and now you stuck a point on it. Graphs can cross their horizontal asymptotes. You have to look in your graph, or you have to test points to find out if it does. They can't cross their verticals. Okay, so it's just something that does happen. All right, I got to keep going. So let's see. What's a y-intercept? I forgot to put that one down. Put in 0 for x, and I will have a 5 on the top, and on the bottom I'll have a -4. Right, -1 times 4. So 0, -5/4 would be 0, -1 1/4, so that's about right there. All right, my vertical asymptotes were at 1 and -4. Okay, what is happening on this graph? Let's try a few points. Maybe I already got the -5, 0. Maybe I should put in -6 just to see what's going on there. If I put in -6, I'll get -1 on top. If I put in -6 in the denominator, I'm going to have -7 times -2. -7 times -2, +14, and I did do that. So that means it's still below. How could that be happening? Oh, that's strange. It's like barely underneath there, isn't it? All right. Oh, I'm going to go in the graphing calculator in a minute. This one's kind of crazy. And I wouldn't put one this intricate, most likely on a no calculator quiz. All right. I'm not going to do that to you. Let's see if we can get at least something over here. Let's put in 2. And I'll check something out in the middle as well. So I'm going to check this right side. If I put in 2, I'm going to get 7 on the top. And then I would have 1 times 6, 7, 6. So that's positive just 1 something. 1 point. So I know I'm in that section. All right, so my guess is it's going like this. Maybe you don't want to write my guess yet. And something's going on in here that I got to figure out. I think this crosses, well, I've done this before. It's not like I never saw this thing before, but this was positive. It actually comes under here and then runs up that way. Oh. Okay, so it crossed its asymptote, but it was coming from up high. Let's go in the grapher and look at it real quick, and we can see the hump that's in the middle. It's not a twist in there. Okay, so what is that graph? Was x plus 5? Put a parenthesis around it. Minus 5. Divided by, and then we had the denominator, x minus 1, x plus 4. Okay, this is going to be tricky. If you're going to put that in the grapher, you need a double parenthesis here. Because you got to tell it that all of this, since it's in factored form, you have to type it like this. Otherwise, you'd have to FOIL it out or redistribute it. And then at that, when I get to the end of this x plus 4, I have to double parenthesis. Okay, so what happened is it crossed very slightly over the the horizontal asymptote on this side, and this side it doesn't. Okay, and then it does that weird twist in the middle. And we can kind of tell the shape now by looking at the values we had there. Do we have any x-intercept? No, not in that section. That was all we had. All right, so it did kind of came up pretty high and then went across that way and down. We did have our y-intercept plotted already. All right, that's that special graph. Can we turn now? All right, so now we've got one that has discussion of point discontinuity. Yes? Oh. Well, I kind of left that blank for a reason. I didn't even put it into my notes. What did I write when I went over this last year with somebody? With my class, excuse me. I wrote all reals except y can equal 0, but is that true? So we actually did hit a y value of 0. So I'm leaving the range out of it because I didn't inspect it well enough to see if there are any strange exclusions, but I'm pretty sure it's all real numbers. That's what I'm thinking it is because it did hit its asymptote. Good question. I need to find a good explanation from that. I need to think about that and go back to some old stuff and try to be able to explain to you why sometimes they cross and why that's okay. In some cases, graphs do have point discontinuity, and that's when there's a common factor to both the numerator and the denominator. See how this has x minus 1 in both the numerator and denominator? So it would reduce to 1 over x plus 3. Now, that discontinuity it's like there still is that exclusion from the domain of 1, but your point that you find here has a hole, and that's where x is 1. So you actually can find the location of it by plugging in 1 into the reduced format of the equation. So what would I get if I plugged in 1 into this? I would have 1 over 1 plus 3, which would be 1/4. You see how it's really close here to the x-axis? That's where the hole is. So what you have to do is put a hole, sort of like, remember when we did the piecewise graphs? We had to have a hole at the end of one of them where it was not included. All right, let's do a couple of examples. All right, this, guys, is simply a summary of everything that we've talked about. If x minus b is a factor of both the numerator and denominator, then there's going to be a hole in the graph at the x value of b. Plug in the b value into your reduced equation to see exactly where it is. Okay, I don't know if I really need to reread all this to you. Maybe that's kind of a waste, so let's just skip on to the next question. Oops, I need to do some erasing first. All right, so what we're going to find out on this one is this has a discontinuity, or hole in the graph, because the numerator factors to x plus 7 times x minus 1. That shows that I have a common factor to both the numerator and the denominator. So if I cancel that out, I end up with y equals x plus 7. What kind of graph is a y equals x plus 7, guys? Yep, it's linear, right? I heard linear, I heard a line. Great. You got it. So, what are the x-intercepts? Well, what makes the numerator 0 would be only one thing now because we canceled out, and this guy is telling me where there's a hole. Okay, so we have a hole at 1 something. Where would it be? Well, take the 1 and plug it into our reduced equation. 1 plus 7 is 8. So at 1/8, we should have an open hole. I'm going to go ahead and put it on my graph. And then I'm going to say, well, where do I have an x-intercept? Well, that's at -7 because that's the only 0 left in the numerator. I'm going to put a point there. Y-intercept would be if I plugged in 0 for x, which would give me 7. 0, 7's right there. And then we just said it's linear. What's the slope of that linear line, that line? That would be 1. So, check it out. Up 1, right 1. Don't fill in the dot, but up 1, right 1 from there. Up 1, right 1. We got that hole still. Down 1, left 1. We get some more points. And we should hit everything. And I am hitting all of my spots I expected. So to fill in the rest of the questions here, is there a vertical asymptote? No. Is there a horizontal asymptote? Okay, there are none. All right. So the vertical asymptotes, guys, those are your end behavior asymptotes. All right. The domain here would have been all real numbers except x can't equal 1. Okay, I think we have 1 or 2 more. Just one more? Oh, that's looking fancy. Let's see what we got. All right, there's a graph. We've got x squared in the numerator, x squared in the denominator, so this is equal weight. Okay, so I see that the leading coefficient of the numerator is 1, denominator is 3. So that tells me the horizontal asymptote would be y equals 1/3. Okay, 1/3, it's barely able to be graphed on here. I'm just going to have to estimate it. I know I'm closer to a half. All right, then I've got x-intercepts. Is there anything that will make that numerator 0? X squared plus 1 equals 0. X squared equals -1. What happens if I take the square root of -1? I get an I answer. So there are no x-intercepts. You can put in 0 for x. Oh, no, I can't, because then the denominator would be 0. So there are no y-intercepts. And then wholes, any common factors to the numerator or denominator? Well, the denominator factors to 3x times x minus 2. So vertical asymptotes, x equals 0 and x equals 2. Still need to do your assignment. I know we had a couple of interruptions that slowed us down, but I will be finishing this. I'm going to finish the graph, put in my vertical asymptotes. We ran out of time in that class, but we'll finish the graph. No holes. All reals except x can't equal 0, x can't equal 2. Okay, if I did a t-chart, put in -1, I would have 2 on top. And if I put in -1, I would have 3 plus 6, should be 9, -1, 2/9. 2/9, ooh, is smaller than a third. So it's running along the asymptote this way. I paused again, but here we go. There aren't any y-intercepts, so we have to run along the y-axis for that chunk. And then to check what's in the middle, if I put in 1, 1 squared plus 1 would be 2. The denominator would be 3 minus 6 would be -3. So 1 -2/3. I really would need to check on some of these other sections. So we actually could go into the graphing calculator and check what this thing does. What number is this? This is number 9. And I'm going to have to come back later because I've got class.